Hello everyone. So welcome you all in today's session. So today we are starting a new chapter, permutations and combinations, right? So this is a very important chapter of NCERT Mathematics for class 11, right? So we will discuss all the questions related to exercise 6.1. So be attentive and be ready with your pen and notebook. We will discuss many important concepts and many important formulae throughout the session. So question number 1 is, how many three-digit numbers can be formed from the digits 1, 2, 3, 4, and 5, assuming that first one is what? Repetition of the digit is allowed. Repetition is allowed. But in second, repetition of digits is not allowed, right? So always remember, whenever you solve any question related to permutation or combination, first of all deal with restrictions, right? So if we talk about this question, so here in first part, repetition is allowed, right? So here we want to make three-digit number, so I'm writing three digits here. So I have created three places, right? This will be what? This will be unit digit. This will be, yes, tens place, and this will be hundreds place, right? So now what is the restriction? Repetition is not allowed. And if we see these five numbers, so these all five numbers are what? They are non-zero digits, right? So otherwise, if there is any one of the number is zero, suppose you have to make three-digit number from the digits 0 to 9. So then we cannot take 0 at hundreds place, right? Because 0, 1, 2, this cannot be a three-digit number. But here, all five are non-zero digits, right? So we can start from either from hundreds place or units place, right? So here repetition is allowed. So if we start from units place, so we are having five numbers, right? 5, 1, 2, 3, 4, 5 are there, and this unit place can be filled by five different ways. We can choose any of the number 1, 2, 3, 4, or 5, right? So if repetition is allowed, so same we can done for tens place, and same can be done for what? Hundreds place, right? So now you know that principle of multiplication. So if this place can be filled by five ways, this will be filled by five ways, this will be filled by five ways. So together it will be done by how many ways? 125 ways, right? So now if we talk about question number 2, so here repetition of the digits is not allowed. If not allowed, so what we will do? Suppose we are starting from hundreds place. So hundreds place, so it can be filled by five ways. But for tens place, we are having only four numbers, because after every arrangement, total is getting small, right? So 5 into 4, so then for unit digit, we are having only three numbers. So 5 into 4 into 3, because of multiplication principle, so answer will be 60. So in this way, you can solve both first and second parts of question number 1. I hope everybody is clear. This is very easy question, but majority of students, so they get confused while numbers are non-zero, or simply it is what? You have to make three-digit number and digits are 0 to 9, right? So then for first, if you write simply 10 into 10 into 10, so that will be wrong, right? So then what you have to do? First of all, you will read the question carefully. Repetition is allowed, right? But at hundreds place, you cannot write 0, right? So for hundreds place, it will be 9, and for tens and unit digit, it will be 10 and 10. So total, it will be 900. So that will be the first part. And if second part same, that repetitions of digits is not allowed. So then again you will start with what? Hundreds digit. So 100 digits can be filled by 9 ways, right? So now out of 10 these digits, one was 0 and remaining 9 digits. So they were what? Non-zero. So we have taken what? Any 9 non-zero digits for this hundreds place. And for this tens place or unit place. So it can be like both can be 0, 0. Suppose you are choosing 1 for hundreds place, and for tens and units you are choosing 0. So 100 is a 3-digit number, that is not an issue, right? So for next one, it will be what? So here repetition is not allowed. So 8 are non-zero digits and 1 is 0. So 0 is also possible for tens place. So total we are having now 9 digits, right? So 9 into 9 into 8. So this will be question number 2. Second part, if repetitions of the digit is not allowed and instead of these 5 digits, you have 0 to 9 complete digits, right? So I hope everybody is clear. So now let us move to question number 2. Here, how many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, and 6? If the digits can be repeated, means repetition is allowed. First of all, we will deal with restrictions. So repetition is allowed, right? And we want to make even numbers, right? So again, I'm writing 3 places. This is your unit digit, this is the tens place, and this is the hundreds place. And what is the restriction for a number to be an even number? Yes, it's unit digit. This unit digit, this must be even, right? So we are having 6 non-zero digits. So even numbers. So they are only what? 2, 4, and 6, right? So if we talk about unit digit, so unit digit can be filled by only these 3 digits. If we place 1, so that number will not be an even number, right? So now let us fill unit digit place. So we are having 3 numbers. So if we choose any of the number, so this can be done by 3 different ways. We can either choose 2, 4, or 6, right? So this unit digit can be filled by 3 different ways. So now repetition is allowed. So out of 6 numbers, we have taken only 1 number. So now if repetition is allowed, so these remaining 2 places, so they can be filled by any of the numbers, right? It is not given like only at unit place there is an even number, right? So this question can be framed by different ways. So finally, what will be the answer? 6 into 6 into 3, it will be, yes, 108. I hope everybody is clear about this question, right? So in this way, we can solve question number 2. So let us move to question number 3. So here, how many 4-letter code can be formed using the first 10 letters of the English alphabet if no letter can be repeated? right? So again, we want to make 4-letter code. So we have made 4 places, right? So now same process, just like previous one. This time, first 10 letters of the English alphabet, no letter can be repeated. So if we start with first letter, so this can be filled by any of the letter, right? So we are having 10 ways to fill first place. But now repetition is not allowed. So next will be done by 9 ways. So then 8 ways, then 7 ways, right? So after every arrangement, your total is decreasing when repetition is not allowed. But in case of repetition is allowed, it will be filled by same number of ways, right? So if repetition is allowed, so then answer will be 10 into 10 into 10 into 10. But this time it will be what? 10 into 9 into 8 into 7, right? So yes, calculate this one. What will be the answer? 10 into 9 into 8. Yes, it will be 5040, right? So in this way, you can solve question number 3. Let us move to question number 4. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each numbers starts with 67 and no digit appears more than once, right? So what are the restrictions? Restrictions are each number starts with 67. So now we want to make 5-digit number. So already 2 digits are given, right? So we want to fill only 3 remaining places, right? So first restriction is number starts with 67, right? So next one is what? No digit appears more than once. So guys, first of all, look at from 0 to 9. Many students, they get confused. They write only 9 digits from 0 to 9. But from 1 to 9, you are having 9 digits and 0. So it means total, yes, 10 digits are there. If we talk about from 0 to 9, right? So it is given no digit appears more than once, right? So we have already used 2 digits. So we are left with what? Only 8 digits. So this place, third place, so that can be filled by 8 ways. So then next one, 7, then 6. So again, we are using that principle of multiplication in counting. So that will be what? 8 into 7 into 6. So that will be 336. And this is the answer, right? So in this way, you can solve question number 4. So let us move to question number 5. Here, a coin is tossed 3 times and the outcomes are recorded. So how many possible outcomes are there, right? So always remember, whenever we toss a coin, what is the possibility? Either it will be head or tail, right? So we are having how many total outcomes? If we throw a coin once, there are 2 outcomes, right? So suppose if we throw that coin again, right? Suppose we are having head at first time. So in second time, it can be head or it can be tail, right? So you're having what? Head, head, or head, then tail. If you have got tail in that first toes, so then it in second one it can be head, so tail head, or then yes, in both cases you are getting tail tail, right? So if you toss a coin once, so there will be 1 plus 1, 2 outcomes, right? if you toss a coin two times, so there will be one, two, three, four, four outcomes are there, right? So again, we will make the same, this tree. So H, H, so then it can be T. If H, this can be T. Then again H, T, H, and yes, T. So by this, making this tree, you can solve so many questions related to this, like questions related to coins, tossing a coin, or questions related to probability. We will solve questions related to probability by using this tree, right? So this is very, very like important method, or you can say a trick while solving questions related to probability, right? So we are having 1, 2, 3, 4, 5, 6, 7, 8. So total how many outcomes are there? Total 8, right? Or in other ways, if you want to apply that multiplication principle, so if we throw a coin once, so there will be two outcomes. If you throw it again, so then again there will be two possibilities. In third case, it will be again two. So again, you will get the same answer, right? And always remember, whenever we have any question related to coin, right? So base is always 2. And if question is related to dice, right? So then base is always 6. And number of times you toss a coin or you flip a dice, so that will be what? Raised to power. So I am just writing n. So in case of coin, total number of outcomes will be 2 raised to power n, and in case of dice, it will be 6 raised to power n. So if coin is tossed 3 times, so directly without like writing this tree or without using this formula 2 into 2 into 2, you can directly write 2 raised to power 3. So that will be 8. If it is tossed 5 times, so then 2 raised to power 5, right? If a die is tossed, if die is flipped 5 times, so answer will be 6 raised to power 5. So that will be total number of outcomes, right? So let us move to question number 6. So in this question, 5 flags of different colors are given. So now question is, how many different signals can be generated if each signal requires the use of 2 flags, right? One below the other, right? So if we read this question carefully, so just like previous questions, here, like we had already discussed, language plays an important role in many mathematics questions, right? So here, 5 flags of different colors are given, and what we want to do, we want to arrange 2 flags, right? This is just like 5 digit, 5 digits are given, and you want to make 2 digit number or 3 digit number, right? So don't get confused with this language. So simply, if you understand the question, so at first place, each signal requires the use of 2 flags, one below the other. And how many different signals means repetition is not allowed, right? So for first flag, you're having 5 choices, so that position can be filled by 5 ways, and second will be filled by 4. And same that multiplication of principle, you will get 5 into 4, answer will be 20, right? So in this way, you can solve question number 6. And this is all about your exercise 6.1, right? So guys, if you like this session, so please share this with your friends. And if you have any type of doubt, you can write your doubt in comment section. I'm waiting for your comments, right? And for more interesting educational videos, you can subscribe Arena World Education. If you have any type of doubt, you can also use our email ID, or this is our WhatsApp number, right? You can post your query on this number. So thank you guys. Bye bye. Take care.